Swayam Prabha. Digital India. Educated India.
Now, usually we talk a lot about mechanical properties while designing structural systems, but there are also some non-mechanical properties which are very, very important. Essentially, they are all associated with the 5 senses which we have, even taste we can include, but mostly not the taste part. But when you talk about construction, touch, because you want whatever construction systems or facilities, you want the texture is also very, very important. You do not want everything to be rough, but sometimes you want rough surface. So, touch, feel is very important, sight, smell, hear, all these are very, very important, and we do consider these things while designing material systems. So, I am going to cover these 4 aspects only here today: acoustics, smell and aesthetics and thermal comfort. Okay. Acoustics is associated with the ears, right. So, you have to, if somebody is speaking in a room where you are sitting, you need to be able to hear the sound very clearly. You do not want echo. So, these are some of the things which you might be seeing in many places where you visit. You will see a lot of this perforated these wall elements, or these are the roof elements, or if you are in an auditorium, you will see some cloth or cloth material on the wall. These are all sound absorbing materials. Okay. If you replace, let us say you are in an auditorium and you replace these cloth material with like steel plates or some metal plates, you will not be able to hear the program very clearly, because there will be a lot of echo. So, these are very important aspects of design, and materials have to be chosen in appropriately. So, what they do and what is the working principle here, you can see on the left side here, there are 4 arrows which indicates how the sound waves penetrate into the sound absorbing material, and then it tries to absorb the sound so that you do not really hear the echo. You can see on the left side, this is the acoustic absorbent or the noise absorbing material, and this is the sound waves, and it goes in and it does not come out. Okay, that is the whole idea. Now, you can see here the incident sound, and some of the sound is absorbed by the green material which is on the rigid wall, and some sound is reflected, some, not all. If you have fully 100% sound waves are absorbed, then you can't hear anything. Okay, it's that's another extreme part of it. So, you have to be able to design it appropriately so that you can hear the sound, at the same time you do not feel echo. Okay. So, here you can see on the right side, I just got these images, nice images from the internet, and very nicely explain the concepts. So, you can see here the person, let us say you are in a classroom or something, teacher is speaking, and then if you, in this case 1, first order reflection you have, and then the person is getting disturbed there. Okay, you might see a lot of echo. But in the second case, you see these 3 yellow sound absorbing material or board on the wall. In that case, there is actually no echoing. See, only this person, this red arrow, it's hitting this, and then it is getting absorbed there, and then this line also it comes and then it gets absorbed here. So, the people do not feel any, or they do not hear any echo. So, that is the advantage, and these are becoming more and more important in today's buildings. Okay. I would also say something here, and there are few decades ago, when we talk about structural design or building design, anything, the skeleton of the building, it used to be the most cost intensive, or in other words most expensive part of the building. Okay. The construction as such, like the brickwork or the columns and beams, slabs, etc., that used to be accounting for 90% of the cost. But as time passed, we started adding heating, cooling systems or air conditioning systems, paint, interior design, and many other features, when electric fittings, so many things we started introducing into our buildings or structures. And now the cost for that skeleton has reduced, and if you take the overall contribution of the for a construction, the cost of the other things like these interior fittings, finishing work, etc., that has significantly increased. Okay, I just wanted to mention this because these are all non-structural elements which play a significant role both in case of functionality of the building and in case of the cost of the building. This is another noise barriers which you will see. I mean, now in India also we see a lot of these coming up in some places, but this is widely used abroad when you want to curb the or control the noise from the vehicles. So, you can see on the picture on the right side, there are some residential areas here, and that those people do not want to get disturbed by the the sound or noise from the vehicle. So, they have these noise barriers. These are again very surface is uneven in nature. So, they like here you can see lot of perforation. So, the noise gets trapped inside and it gets absorbed by the system. So, the people on outside, they do not really get disturbed with the heavy noise. Noise pollution is very less, and it is important for both human beings and animals in the nearby areas. This is probably an earlier version of noise barrier, earth berm. This is from California. So, you can see like a soil, just a barrier made out of soil, and of course, you have small plants, grass, etc., growing, that will absorb lot of noise from the vehicles. Okay. Now, other thing which we have to worry about is the smell, that is our nose, the sense. The smell of wood, paint, etc., sometimes creates a lot of problem. I mean, I remember many cases where people will have to keep the window open for few months before the foul smell of the paint goes away. So, or if you use some chemicals in construction, that might induce some long term impact it will have some influence, adverse effect on the comfort level. In case people will have to keep the window open, otherwise they will not be able to work. So, you have to choose these are all things which can go in as specifications, technical specifications. When you try to purchase paint, you should ask whether will it have any bad smell and things like that. Okay. I just wanted to bring all these aspects because sometimes we get overwhelmed with the mechanical properties alone, but there are other non-mechanical properties also which play a significant role in material selection. Other thing is aesthetics, and nothing more to talk about this except the fact that we must remember functionality when we talk about aesthetics. Okay, so functionality is very important. Aesthetics should not affect the functionality of the structure or whatever facility we are building, but this aesthetic is definitely dependent on person to person. Something which I like, you may not like. I might like red color, you might not like the red color. So, it is all person to person, architect to architect, this will change. But there are different factors which we can consider while designing the structure. Okay. Now, other parameter is thermal conductivity. Okay. Again, becoming more and more important in today because you are talking about climate change, lot of heat, especially in countries like India, and if you are talking about other part, they were cold countries where you want to contain the heat inside the building because the outside is very cold, and in summer countries where climate is very hot, there you don't want the heat to come from outside to inside the building. So, both ways you want to prevent the exchange of heat through the wall. That is the idea here. So, here is an example photograph which shows again from the internet various elements, wallpaper, plaster, brickwork, insulating wall, rendering, all these can have an influence on, these are different components of a wall, and they all can play a role in making the house or the building thermally comfortable. Yeah, now look at here the thermal comfort. So, thermal conductivity is the rate at which the heat is transferred by conduction through a unit cross section area of the material when a temperature gradient exists perpendicular to the area. So, here you can see on the left side there is a sketch which shows two materials with thermal conductivity K1 and K2, and the temperature or T1 is higher than T2, T1 is higher than T2. Okay, let us say assume like that. So, if the conductivity is high, then you will have faster movement of the heat from one side to the other. So, you want to keep it low, you want to keep it low. Okay. So, here are some example materials at the bottom. You can see I am just going to take this example of brick where you have one with a lot of open space inside. It is by design, and this is a typical clay brick, second picture, and the third picture is a laterite brick which also has lot of air voids inside the, it is a naturally available material and lot of air voids inside, and people use it in the cut in shape of the brick and then use for building construction. And then this is the third one which is a concrete brick, and the fifth one is aerated block. So, third 1, 2, 3, fourth one is the concrete brick, and then fifth one is the aerated concrete block which also has lot of air voids inside. It is made by mixing the concrete with hydrogen, mixing the concrete with alumina powder, and during the reaction the hydrogen bubbles are formed, and then they have lot of these well distributed air bubbles inside the brick, and that is very lightweight brick also, and that also helps in preventing the exchange of heat from one side to the other, both heat and noise. So, these are if you have air voids inside your brick, it is good for both noise control from one room to the other and also from temperature or thermal exchange from one side of the wall to the other side. You can look at this example here. Thermal conductivity for a dense concrete block is very high, okay, and a light concrete block is very low. That means, in the case of a light concrete block, it will take more time for the heat to get exchanged, okay. Whereas, also another example is plaster with the dense is 0.57 or 0.6, and plaster lightweight is 0.2 or 0.18, right. So, you can see that as you have lightweight means there may be some air in it, that is why it is lighter. So, the more air you introduce into the system, your thermal conductivity is going to be low, and when the thermal conductivity is low, that means that heat exchange is going to take more time, okay. So, it is good for it is good to use materials which has low thermal conductivity. Okay. Now, also when you talk about low thermal conductivity, another thing is advantage of all this is typically these will also, like bricks with porous structure or air voids inside will also have high resistance against noise. They will also function like a noise absorbent. Okay. So, for example, in the buildings where you have a wall, if you are talking here, people in the other room need not listen to what you speak, right. So, in such cases you will see actually in today's most of the construction where they use very high quality concrete, you will see that this is becoming a problem, that somebody speaking in one room, the other people in the other room can actually hear. So, you should think about what type of material to be used for interior walls in buildings. We should use, for interior walls, we should use brickwork or whatever the material we use should have good resistance against noise. They should function like a noise barrier. Okay. Now, we talked about various things, and this is the last slide in this, and design concepts. One thing which we look at is strength or mainly mechanical properties. Okay. Then we also look at deformation or ductility or deflection, etc. That is mainly coming from the serviceability criteria. Like for example, I am going to use a case of a bridge. Okay. Let us say this is a bridge here. Okay, and you have a vehicle, okay, vehicle going. Now, serviceability means this bridge should not deflect like this when the vehicle is traveling. It will deflect to some extent, agreed, but it should not be like so much of deflection that you start feeling worried whether you are going to fall down or not. So, that is, there is a limit for deflection. So, those are again looked at through the mechanical properties, but it has mainly the serviceability characteristics or criteria. Then there is a third one, which is durability, which is gaining more and more popularity nowadays because we want our structures to last very long. In such case, it is more of a chemical properties and also mechanical. I mean, I am not saying no for mechanical. Mechanical plus chemical properties are important. For example, one area where I focus mainly is corrosion or deterioration of concrete structures, where corrosion is essentially an electrochemical mechanism, right. So, we look at the interaction between the steel and concrete in a particular environment, whether steel will corrode or not. So, there is essentially an electrochemical feature which we are looking at. So, I can change the chemistry of the steel and chemistry of the concrete so that I can have durable structure. So, it is essentially service life based design or durability based design. We look at, if you want a structure to last for 100 years, you will see what type of concrete will give you 100 years, what type of steel will give you 100 years, like the steel concrete combination will give you 100 years of life. Or if you want the structure to be built only for 20 years of life, you can decide it accordingly. You do not need to then use a material which will really last for 100 years. So, these are all the concepts. So, you have, while you designing something, you should know what is the service life required, how long you want the structure to last, and then you select your materials accordingly. Then sustainability is again another thing where durability is very important, but also you have to look at availability of the material and what about the carbon footprint. There are many aspects which carbon footprint. So many factors we have to consider when we talk about sustainability. People should like to use that thing forever, it should be, the technology should be sustainable, and at the same time that material should be available for as long as possible. So, these are, I am going to call this as 4S for the design concepts. So, you can think about these design concepts. Now, do not worry only about the mechanical properties, you also have to think about other properties while designing structural systems. Now, to summarize, we talked about brittle and ductile behavior, work and energy, fatigue failure. Then we talked about non-mechanical properties such as acoustics, features, smell, very briefly though, but these are important things to cover, aesthetics, thermal conductivity, and also finally looked at 4S design concepts, 4S. These are strength, serviceability, then service life and sustainability.